And what we're doing today really is just using some vocabulary and the fact that we can solve these equations to determine what types of equations they are. So you can title this types of equations. And the way we get these types of equations is by looking at our answers. So there are three different types of equations based off the answers. There's conditional equations, there's identity equations, and inconsistent equations. Conditional equations is when the answer meets one specific condition, such as x equals 2. So when x equals 2, that makes a true equation, so it's a conditional equation. Or x equals 10. Or in general, when x equals any number, it would be conditional. Okay, so if it equals this number, then it's a true statement, a true equation. The identity is when you have the same thing on the left as the right. So if I got like 2 equals 2, then it would be an identity equation. Think about you looking in the mirror, you see yourself back, that's your identity. Same thing here. 2 equals 2, 2 is looking at 2 in the mirror, and boom, there we go. 0 equals 0, that would be identity. You get x equals x. You get 3x minus 7 equals 3x minus 7. As long as the left side equals the right side, it's the identity. What kind of solution do you get when you get those answers, though? When you get like 2 equals 2 or 0 equals 0? Gavin? Not 0. Not undefined. We're going to get to undefined. What's the other one? It's always true. How many solutions are there if it's always true? Infinite, or x equals all real numbers, okay? So this is saying everything would be true. So our answer here is x equals all real numbers. So this is a fancy R, so it's like making a parallel lines and making it into R, and it means all real numbers. So conditional is when you get a number answer. When you get all real numbers, or the left side equals the right side, then it's identity. And then you get inconsistent when you get no solution, essentially. So if you get 2 equals -1, does 2 ever equal -1? No. So that would be no solution. Also, things that we've been thinking about yesterday in our homework, we had a couple of these. So we got like an answer of x equals 2, but because of the restriction, x can't equal 2. So therefore, there was no solution, or the null set. Okay, so inconsistent is no solution or the null set. Remember, null set just means empty, nothing there. Yeah. They can't. I mean, they could have restrictions. Yeah. So these are just the types that, like, once you get your answer, you could do this for any type of equation. You can do it. We'll see it that it comes for a linear equation, quadratic, the rational, like we saw. But based off how your answer looks, like most of the equations that we've done so far this year and are conditional because we're just getting x equals. Okay. Those couple we got yesterday where it was like x equals a number, but it was one of the restrictions, and that would be an inconsistent one. All right, so let's look at this example. Again, here are 3 different types of equations. The directions say solve and determine whether the equation 4x minus 7 equals 4 times the quantity of x minus 1 plus 3. is identity, conditional, or inconsistent. So essentially all we're doing is we're solving that equation as normal, and then based off of what our answer looks like, we'd write conditional, identity, or inconsistent. With me, Tyler? All right, so first thing we're going to do, again, nothing crazy. It's just a regular linear equation. We have to distribute. All right, we'll get all of our like terms together on the right side. And then I'll get all my numbers on the right and the variables on the left. Yes, sir. So there's nothing left on the left side because 4x minus 4x is 0, negative 7 plus 7 0. These cancel and we're left with 1 plus 7, which is 6. Does 0 equal 6? No. So this answer would be the null set, and what type of equation would it be? Inconsistent. Yeah. Nope. You don't have to. Yeah, as long as you don't get it, as long as they're not equal. I was just kind of saying, all right, well, I'm going to try and get my numbers on the right and variables on the left. It just so happens that's what it did. But you don't have to. As long as you're seeing that all those x's cancel and they're not equal to each other then. All right, one more. So same directions. We're solving that, and then we're deciding if it's identity, conditional, or inconsistent. So again, just like I'll give you a second to write that down. Go ahead and write that down. All right, then again, we're going to solve for x, so we're distributing the 9. So I get 9x plus 9 from distributing. Combine our like terms. We get 7x plus 9. So I get 7x plus 9 equals 7x plus 9. It's like that equation is looking at the mirror and saying the same thing, right? So that would be our identity. So it's an identity equation. And you also want to tell the solution. So this would be all real numbers as our solution. Anything we plug in here for both the x's would make a true statement. So we would say x equals all real numbers. And in the solution set, if you remember when we did the set builder at the beginning of the year, we would write as x. That line means such that x is equal to our all real numbers. Yeah, probably. But write that down for now just so you know where that's coming from because your book will show it like that usually. All right, so today you're going to see some questions as you're practicing that are just linears like this. You're solving them as normal and writing the types of equations they are. You'll also see some rational equations as well that you'll need to solve.